Well, hello everyone. My name is Anshua Srivastav, and you might have clicked on this video wondering what exactly is ethical hacking or what is bug bounty hunting, which is quite popular nowadays. So it's not necessary that you need to have prior knowledge before watching this online course. This is for everyone, for a beginner, for an intermediate hacker, or even a professional hacker who's looking to refresh his skills. Now, before I get started, I wanted to get straight to the point, but this is very important to tell you guys that I don't want my online course to be like a lecture which we get, a proper standard lecture which we get in our colleges or in our schools. I want it to be like a conversation we are having about, like two friends would have about a particular topic, and that would be hacking. So let's just get into it. So this is my computer screen right over here, and well, I'll just show it to you. So this is how we will go about, and you can see it over here. You can read all the different topics which I've written. Don't be worried if you are unable to understand some of them right now. You will get to know each one of them. I will explain it to you. So we are done with our introduction. So let's just talk a bit about what is a bug. Let's start a conversation with that. So typically a bug, when you think of a bug, what comes to your mind? I think it would be those small annoying insects which trouble you. And in some way it is very similar. A website bug or a computer bug is something which affects the functioning of a website or an application, and it makes it work in a way that it shouldn't be doing, or it alters it in a way which is not desired by the creators of that application. It shouldn't just do that. Basically, that's what it means. So is every bug harmful? Like, we are talking about hacking over here, so, but you might have heard about various kinds of bugs that they exist, but is every one of them harmful? So a bug could be everything. So like if I'm on my screen over here, and let's just say for some reason the Google in Google over here, the last E of Google is not appearing. Well, it's a bug. Like I told in my definition, that it's not working the way it should be. The E should be appearing, but is it a security risk? Is it something you would consider, oh, I have hacked it? Like, no. That's not the case. When we talk about hacking, we specifically talk about, I should mention that, we specifically talk about security bugs that pose a security risk. And what exactly we categorize as a security risk? Well, that's very simple too. Something which would lead you to a certain data, or lead you to a data, would allow you to change that data, or permanently allow you to delete or maneuver that data, which you basically wouldn't have access to normally. So let's just say, again, take an example of Google over here. These are all my accounts over here. So if, let's just say, I was able to get access to another person's Google account, so I'm able to access their data, which shouldn't really happen, because Google promotes privacy, and they obviously want everyone's email to be secure and their account to be secure. That's why they have a selling point over there. But that's what happens. That is a bug. Security bug, again, I'll just recap myself. It's basically something where you're accessing data which you shouldn't be in any form. That's a security bug, and that data you could use it in a real life scenario. So for example, again, just to emphasize on that, if on my Google example, if let's just say I got access to, let's just say, what should we take? Yeah, I got access to someone's email ID. Let's just say they didn't tell me, I just got access to their email ID. So that is data. I got access to a particular data. But knowing someone else's email ID, is there, just think about, is it really a security risk? No, not quite. But if you know the password of that email ID, then that is a significant security risk. Now, what is the difference between the two? Why is knowing someone's email ID and knowing someone's email ID's password? These are two different types of data, but one is considered to be a security risk while one is not. Well, consider consequences. What are the consequences of knowing someone's email ID? You could spam them with emails, trouble them, I don't know, but you just get it. There are not many consequences of that. Whereas over here, if you have access to their password, you will be able to access their emails. You'll be able to access, like Google has many other features, YouTube, watch history. Basically, you will compromise their entire security, privacy, and whatnot. So that is a bug. I hope you understood all of that. Now that we got a basic definition of bugs out of the, what would be considered a security bug and what would be a design or other kind of bugs, let's just go to the next topic. So what is our next topic? HTML and website coding. So now I always give this analogy to anyone I am trying to explain hacking to. Whenever let's just say you have a lock you cannot open, you call a locksmith to fix it, to just open it for you. But how is a locksmith able to do that? How is he able to, let's just say, breach the security of your lock? Because he has idea of how that lock is built. So if he has the idea of how that lock is built, he will also know how to crack it. And that is basically the my motive behind teaching you a bit about HTML and how websites are created. To crack down and to find these flaws in websites, you need to know how they are built. And every website, even this, by the way, if you don't know, I'm using Chrome over here, and if you want to see the code of any website, you can just right click over here and go to click inspect, or obviously Ctrl+Shift+I. You click over here. Now this very complex looking code is actually the HTML code. Every website is made with HTML, and as you can see, this is how a standard HTML page would look. This of course is Google, so it's a bit complicated, but you'll get it. So this is HTML. Over here we have these, so you have these greater than and less than signs in what we call in maths, and inside these we have what we call HTML tags. Alright, so every HTML page, regardless of the website, it will start with this tag, which is called the HTML tag. HTML. Now Google has added, of course, things of their own. These are what we call attributes, and attributes, I think it's pretty self-explanatory. You're adding an attribute to that tag. So like they have lang is equal to Ian. Basically it means that the language over here is equal to English. Alright, and then underneath the HTML tag you have other tags, like you have the head tag, and head tag is something very, I would say, something which comes under more advanced HTML coding, and it is not of that important when we consider hacking, so I would just leave it over here. But the main part of what you really need to understand about HTML and hacking and how it's connected to hacking is the body tag. So again, what I like about HTML is that it is these tags, they are more or less self-explanatory. So body tag, just pause this video for a second and think what would body tag mean, right? I hope you have thought a bit, and let's see if you're right or not. Body tag basically means that whatever you write, whatever code you write within the body tag, that would appear on the main web page. All right, so like underneath the body tag, see, if I click if I move my mouse over the body tag, it just selects all of this area, because whatever you write underneath the body tag is what actually appears. All of this you see over here, that is code, and that does play a significant amount of part in how Google works, but none of it is actually appearing in front of the user. What appears in front of the user comes underneath the body tag, like you see over here. So you could just select, like you can see we have this tag over here, it shows what area it covers. All right, so these are the basics of HTML, and I know it might seem a bit daunting at first, but trust me, HTML is a very simple language. And like this you can, and just to emphasize again, This is called the Chrome Inspector, and it is a very good tool to see the HTML code of a website. Ethical hackers use it all the time. It's very helpful. Now, coming on to another basic part of HTML, that is when you're done with a tag. So let's just say you are done writing what you want to appear on your web page. You will have to close that tag. So for example, you have the body tag over here. You want to write what will appear on the body. You have written all the code for that. You have specified, I want Google written over, I want this search bar over here. When you have done that, you have done doing all of that, you have to close the body tag. And this is not only for the body tag, this is for all HTML tags in general. When you're done with them, you need to close them. There are some tags which you don't need to close, but most of them you need to close them. So how do you do that? Again, greater than I don't know what do you call this, greater than or less than sign, but where it's greater than signs, and you have a slash and then the name of that tag. That's how you close it. Just everything is similar to how you open a tag, just the slash over here. Then you have body, and then again greater than less than sign, and then as you can see, the HTML tag is closed over here. So once you have done writing all the code of your web page, you close the HTML tag. Well, that's HTML. But front end and backend. So these are two new terms I just introduced. I'll explain it to you. So what HTML is what we consider a front-end language. Creating a website and managing it requires many languages, not only one language. HTML is a part of it, and HTML comes under front-end. So what is front-end? Front-end is anything which is visible to the user, and the code is basically visible to the user. That's all you can say. So if any code, whether it be written in HTML or JavaScript, that is visible to you, that is called the front end, which is visible to the user. What is the back end? So the back end, as you can, again, pretty self-explanatory. Back end is what is visible to the website owner, the server owner, or let's just say in this case the Google employees or Google administrators. And on the back end you have a database where all your records are kept. You have the server, and the server also needs codes to work. That is called the backend. And we have some backend languages like you have PHP. So like HTML runs our front end web page over here. PHP runs the server. So the actions the server performs. So if I click over here and I don't know, let's just search Google Tag Manager. So whenever I clicked the Google Tag Manager over here, a request went to the Google server. See, and over there in PHP language, the server analyzed, okay, Anshraj is asking for what is Google Tag Manager. So the code went to its database. Okay, database, tell me whatever information you have about Google Tag Manager. Database send that information back. How did database find out that information within itself? There's a language for that too. That is called SQL. The database found that language, it sent it to the server sent it back to me, and it is being displayed. Well, that sounded like a very complicated process, but here you are, it happened in seconds. In fact, 0.56 seconds, Google trying to emphasize that. And if you haven't understood that, then I'll explain it to you better with the help of a diagram. Let's just see. Yep, over here we have this one. All right. So as you can see, yep. No, this one. This is the exact one. So let's just ignore the sense for a bit. You are the client over here. You are the one requesting and accessing the website. Let's just take Google over here. So what happens is that you send a request, like I said, okay Google, I want information about Google Tag Manager. Let's just say I want information about Japan. Google, give me what you have about Japan. Your search about Japan, that request that you want data regarding Japan, it goes to the router. Then it goes on to the internet, the World Wide Web. Then slowly it reaches Google's server. I say it's slow, but it's pretty fast process. So this over here represents the server of the website you're trying to request data from, and in our case it's Google. So what happens is that there are servers over there, so the servers process your request. There are, like I told you, there are languages to do that, mostly PHP. They process your request. Okay, Ansharja is requesting information about Japan. Then they go to the database, again pretty self-explanatory if you do not know, a place where all the data is stored and managed. So over there's all the information about the data, all the data that the website contains. So it basically tells the database, okay, give me anything you have about Japan. And the database, to find what it has about Japan, it uses another programming language called SQL. SQL basically sorts the database. Okay, let's find out which column or where is my information regarding Japan located. It finds it, it retrieves it, it sends it back to the server. Server sees it, okay, I have got the information about Japan, let's just send this back to Ansharja, and then the information comes back to me and it is displayed to me. Pretty complicated, but like I said to you, it happened pretty quickly. And JavaScript, I think I mentioned JavaScript before. JavaScript is another front-end language, but you do not really need to know it right now. I'll explain it to you in this course video only. Alright, we are done with HTML and website coding, and I already explained you the difference between normal and a security bug. So let's just talk about OWASP top 10. Alright, so till now we have understood what are bugs and how a website is basically made. So let's just get into the real part of hacking. And OWASP top 10 is very important. Then actually what I have written beneath as part of what OWASP top 10 is. So you might be wondering, Ansh, what is OWASP top 10? Just tell us. Alright, well, let's do a Google search. OWASP top 10. Let Google send a request. The Ansh requests information about what OWASP top 10 is, and database pretty quickly, I must say, has given me that information. So OWASP basically is a community-based organization for cybersecurity researchers, and what it basically does is that it creates tools to help the community. But what our main focus over here is the OWASP top 10. And what OWASP top 10 does is that it identifies the different types of security bugs which have been the most common, and that is what we call OWASP top 10. And that is why whenever anyone starts ethical hacking or they want to get into bug bounty hunting, their first goal should be to learn and master these top 10 bugs, because of course these are the ones to be found more commonly, right? So first we have actually I've written it over here, so I'll just go with this order. So first we have XSS, and XSS is, I would say, the one which personally I would say you can find it most commonly. What happens in XSS is that, alright, again we are back with Google. So right now over here, in Google you search over here and you search basically keywords or something you want to find, but what if I start typing HTML code over here? Let's just say I type HTML, and like I told you, this is HTML code. This is not normal. So how would Google react to it? Well, it searched it, but sometimes what can happen differently. Instead of the website functioning normally, and like in this case it just searched HTML with those greater than and less than size, that's normal function. But sometimes websites can take this code and execute it. After all, they are made of HTML, and this HTML is becoming a part of that website now. Alright, so this is HTML code. You enter it, and instead of the website filtering it out and functioning normally, the website executes it as a part of its own code. And now you know, if I can execute HTML code on a website, that can be pretty harmful. So this is a type of code injection, and again Code injection. So code injection basically, again, you're injecting a particular type of code into the website. You're injecting a particular type of code which you're not expecting to run normally. You want it to become a part of the website. That is called code injection, injecting code. Over here it didn't get executed, but I'll show you an example where it did get executed, and that is when it becomes harmful. So over here something similar, like you have over here you simply have a form. You might have seen such forms many times. It says enter your email below to register, blah blah blah. The person has entered the email, and now it asks us to repeat that email just for confirmation, as you might know. But instead of entering his email, or what normally a person would do, he enters an HTML code. As you can see, it's the script tag, and he has opened the tag and he has closed the tag. And just I'll tell you a bit about the script tag. Script tag is basically used to integrate JavaScript into our HTML page. And JavaScript is what the language which you use for creating all these pop-ups and alerts, which you might see on a very regular basis on your website. So JavaScript basically makes a website more dynamic. But at this level, you really do not need to know much more about JavaScript, just to know how know a bit of basics about it, so that if you are testing for XSS, you can test for JavaScript, because mostly JavaScript is what is accepted by companies in terms of what they consider as a XSS bug. If you are able to enter any other HTML tag, most probably they won't accept it, but JavaScript is considered as a code injection, and specifically XSS, like we have been talking about. So here you see, normally what should have happened is that this website should have returned an error that, alright, your email address above and your repeat email address which you're writing again, it does not match, right? That's what should have happened. But what really happened is that this got executed. Alright, so that's why you're seeing this pop-up over here. This wasn't a initial part of the website, but now it has been integrated into the website. And over here we can confirm that an XSS bug exists over here. So this piece of code that we entered, that this person entered over here, it is what we call a payload. Alright, and this is the most basic payload which you need to know. So like I can just type it over here in Google too. This is the most basic consideration of XSS: script alert, alert 1. Alright, it's so script. Alright, this is a code. Now it didn't get executed, but you probably know that if it got executed, then we would have a bug in our hands and we would need to report it to Google. So this is the most basic payload. But now if we know this, and if we also know that this is the most basic payload, then the companies and the security engineers of these companies also know it, and they would take steps to prevent this from getting executed. So what do they do? What they basically do is that they create a blacklist. So you might have heard people getting blacklisted from certain places or something like that. This is pretty similar. They create a blacklist of words of code. So why this didn't get executed over here is that Google on Google's backend side, they have created a list of words which their server filters out. So if I enter this script tag or try to enter any other HTML code, then what the server does is that it sees it matches. Alright, Anshuraj is searching for Japan. Alright, this doesn't come under blacklist, let it go. Anshuraj is typing script tag. Alright, this is harmful. Now don't let it execute and just remove it. So that is what Google did over here. But there are ways that you can counterfeit it. And that simply is that you try to find bypasses or other ways to write this. So what could be the other ways to write this? you just go over here and you can simply type on the internet. Let's just see, XSS payload list. Again, OWASP comes in handy. I told you it's a very good community based organization here. So what you basically see over here is just different versions of writing JavaScript. And what our main motive of doing this is to defeat the blacklist on the server, on a particular website server side, so that we can execute our bug. Like you can see over here, you have got script src is equal to this. Now you could try and understanding what exactly these payloads are doing over here, but most of the times what ethical hackers do is they just try and copy paste it to the place where they're trying to find a bug and hope that one of them executes. Over here it's just nothing. You're typing mostly the same type of code, that script alert one, and you're just trying to, let's just say, change its clothes so that it doesn't get recognized by the security guards of Google, which is the blacklist. Alright, I hope this is pretty clear. I'll just add this cheat sheet list. This cheat sheet list would be in the description of the video, so if you want to access this, you can access it over here. But there are other types of XSS too, and there are basically three types of XSS which are mostly significant, would be significant to you. First is self XSS, second is reflective XSS, and third is stored XSS. Again, first of all, try to understand them by the terminologies. So self XSS means that a particular user would have to enter that code themselves, and I'll just show you a example of that. So this photo which I showed you over here is self XSS. So what happened over here is that the user entered this code over here. All right, it got executed, well done, but this particular code, it didn't get stored in the website. If you refresh this page, it would be back to normal. And if you want if the hacker wants their code to get executed again, they will have to type it again. So which is why it is called self XSS. If you want to harm, if a black hat hacker, if a bad hacker wants to harm a particular victim, they would have to send this code to that victim and make sure that the victim copy paste the code and does that. That is why copy paste the code and make sure it enters in the desired input column. That is why many companies do not consider self XSS, because it involves a bit of social engineering. What is social engineering? Basically trying to convince the other person to do certain actions, and these actions are out of the company's control. For example, if I send an email to a stranger telling them, give me your Google password, and they give me that Google password, so how is Google responsible in this? That's the problem of the person. This is what we call social engineering, and the amount of social engineering which comes to play into a bug also affects its impact. Alright, so if the amount of social engineering in the bug you found is very high, then the chances are the company won't consider it, or if they would consider it, it would be of a very low impact and hence a very low payout. So over here you can see for self XSS, you will have a black hat hacker or a bad hacker would have to send this particular code to the victim, then require the victim to type it and all that, which is why many companies don't consider it. Then you have reflected XSS. So a very good example of that would be, let's just search Japan again. Japan. So as you can see, I search Japan where the results come up, but also you can see is that over here in Google's URL for this, there's a query for Japan. Now what if instead of this query I type script alert? Alright, caps lock was on. Alert 1 script All right. So as you can see, it got searched. I didn't type it in the search bar. So what exactly is this? So this is what we call a GET request, or a GET type of information. So what happens is in this is that the request of the information, like let's just roll it back to the diagram which I showed you of the data transfer, how the user requests data from the server and how the database fetches it. So there are two types in which a user can, a web application can request information. First is GET and the other one is POST. GET means that the requester, like what I am requesting from the web server, it is shown in the URL. Like you can see, it is shown over here that I am requesting script alert 1 script. But if it is not shown over here, for example, it doesn't get shown over here. Let's see, like a search, blah blah blah. All right, this is also GET because it is getting shown over here. So let's just assume it doesn't get shown over here. That is a POST request. That is something you won't be able to see on your screen right now, like the exact request that the website is sending to its server, but you will be able to see it with a proxy, but not on your screen. That is a POST request. This you can see over here. So this is a GET request, and this URL, if I copy it and go to an incognito window, incognito is also very useful for you guys and other hackers too. Why is that? Because incognito, when you open an incognito window, you are basically acting as a second user in your own computer, and that way you can test cases for a hacker and a victim and how it moves on. So for example, if I send this to my victim, I send this link to my victim, the victim clicks on this link and boom, it opens up. Right now there is no XSS over here because of course Google is secure, but what if the website was harmful and the XSS got executed? Like the user didn't have to do much actually, the victim actually. They just clicked the link and it opened up and boom, there is XSS. Alright. So the level of social engineering involved over here, that is very less. And like I said, if the level of social engineering involved over here is less, the impact of the bug increases. And this is what we call reflective XSS. That you only uses a link and boom, the XSS code is executed on the user's side. So I guess I have an image for this too. Yeah, reflective XSS. See, as you can see over here, in this website, this is actually a localhost website. So over here in the GET request, instead of the normal query, the person added test script 1 alert. This is basically another XSS payload, and it got executed. All right. So this is reflective XSS. And another viewpoint that I would like to introduce to you is, like I also said while I was explaining bugs, that you need to consider the impact that it would create to another user, or it would create to the company or the website itself. You would consider that in other cases, but in XSS you do not need to do that. You only need to show the company or whatever your organization you are doing research for that XSS exists. You do not need to show them how they will need to take out, how a real life hacker could take out data, how he or she could impact the victim. You do not need to show that. You just need to show that it exists. In other bugs, you will need to show that what the impact of that bug is, and I'll explain how you should do that too. Don't worry. I hope our conversation is going fine. So this was reflective XSS, and the third type of XSS is stored XSS. So till now, both of these XSS, self and reflective XSS, they execute when the code is given in as an input. So in self XSS, the victim had to give the XSS code as an input. Over here, the hacker is already doing them, but for the victim, you are using a URL. But in both of them, the input had to be given, and if you refresh the page after both of the codes has been executed, that change that the code brought, that would be gone. So if I refresh this page, this alert pop-up window, that would be gone. What does this mean? This basically means that while your code was executed, all right, the fault was there, but this HTML code, it didn't get integrated with the website's code. Okay, so I mean, yeah, it was harmful, but not that harmful. Now just think about it. What if you enter the code and it gets integrated into the website permanently? That is exactly what stored XSS is. It becomes a part of the website's code, and since as you can already imagine, it would be pretty harmful. Since it is pretty harmful, it is also pretty rare to find. The most common type of XSS which people find are self and reflective XSS. Stored XSS are pretty rare. But on that note, we have finished with XSS. The main reason why I put a lot of concentration onto XSS in our conversation was that this is a bug which is very easy to find, especially for beginners, and it is very common to find as well. And you do get paid a lot of it if you want to go into bug bounty hunting. So let's just continue on with our conversation. The next topic of our conversation is Burpsuite. So what exactly is a Burpsuite? You might have heard about proxies. And what exactly is a proxy? This one. So these requests which are being sent, again coming back to a Japan example, when I search Japan in 0.5 seconds, I have the answer to that. What I searched about Japan, I have information about Japan, but I couldn't see what exactly did Google send to this. Did Google send to its web server? What exactly was it that made this information comeback happen? And to do that, you would need a proxy. Proxy is basically like a middleman. It intercepts the web request, it shows it to you, and you can perform many actions on that web request through it. And a proxy is a hacker's best friend. All right, get that in your mind. A proxy is a hacker's best friend. So what proxy are we talking about today? We are talking about Burpsuite. There are many proxies in the market, but Burpsuite is basically what you would consider as the industry standard. Almost everyone uses Burpsuite, and it is not something which you need to pay for. There is a free edition of Burpsuite too, and in fact I am also using that free edition. It comes with a huge amounts of features. So let's just go on. Yep, over here. Just search Burpsuite. You will go click this link of portsfigure.net. Portsfigure is a company which made Burpsuite. Excuse me, products. So Burpsuite Professional and Burpsuite Enterprise Edition, I think you can already guess it. It is paid, and you really don't need that. All you need to click on is Burpsuite Community Edition and just download it over here. Now I already have downloaded it, and again, one more thing you need to keep in mind, that before using Burpsuite, you will have to configure it, and to configure it, I would recommend you download Firefox. So you configure Burpsuite with a Firefox. Every proxy needs to be configured with the web browser. All right. I would recommend you do it with Firefox. I think it's pretty complicated to do it with Chrome too, and if you use Chrome on let's just say daily basis, then Burpsuite could affect your daily performance of Chrome. So just use it for Firefox. So if you're just researching, then you can open up Firefox, and Burpsuite would be more convenient. Doing it this is also a pretty nifty task, I must say. So this is a very good video I found online. The link to this would be in the description. You can find it over there, and yeah,
this is an ad.
Well, we have ads over here, but this is the video. You can just see it configure Firefox with Burpsuite. It's a good one. All right. So now let's just open it. So to use a proxy, you will have to open the web browser it is configured with, and the proxy itself, of course. Let's just go Firefox, open run as administrator. Then all right, let's just say yes, and Burpsuite. I will also open this as administrator. While these are getting open, let's just have a liquid break. I hope you're getting things right now. What I am trying to teach you over here is the more practical senses of hacking. Hacking is a very vast topic. I don't think so any hacker on planet knows everything about hacking. But what I am teaching you over here is the most practical things and the things that you will actually need in real life. All right. So let's just see. Firefox is open. Not now. All right. So here it is. Firefox is opened. And one more thing which I'll need to remind you guys is that using a Burpsuite and Firefox and all these softwares, it would require you to have a good desktop or whatever type of computer you are using. Like I would say at least have 8 GBs of RAM. Otherwise you'd be in some trouble. Alright, so Burpsuite has opened over here. I think after you follow all the steps over the video which I showed you over here, this link, yep. After you follow all those steps, this is the window which you would see. Do nothing over here, just click next, start Burpsuite. It is starting your project. Alright, pretty simple till now. Let's just let it open up. Alright, Burpsuite has opened up. Now this might seem very complicated, but just take a step back, just see things as they are, and don't let your mind confuse you. It is pretty simple. I'll break it down to you. So the first thing you will see is the dashboard. Dashboard basically shows whatever things are going on, but there are 3 main things which tabs over here which are the most useful for you. The first one being proxy. Proxy, of course, you would have understood. The first thing it does is do this, intercepting the web requests. As you can see, the intercept is on. So what does it mean when the intercept is on? Like I told you about the middleman example. Alright, so for example, there is a nightclub and there is a bouncer of the nightclub. So let's just assume that a person going into the nightclub is like data transferring from a website to a web server. Alright, they are going in, and a bouncer or a security guard is the proxy over here. So when our intercept is on, basically what we are telling our bouncer is that just hold on to this person going in. We want to inspect it. Alright, so we are inspecting whatever they are going. And if you turn the intercept off, it means that your bouncer is letting everyone go in. So for example, if I search something over here, turn your intercept. Before trying to intercept a request, you need to turn the intercept on. So let's just say I type hi, I search it over here. So as you can see my internet is pretty good, but this request isn't going forward. Why is that? Because our intercept is on, our security guard has blocked the request. So if we click forward over here, it means it is allowing the request to go on. These are some, see, this is the exact request. So this is exactly what Google is sending to its server to retrieve the data of whatever we searched hi over here. We could actually see, if I type hi over here, you could see the query over here says hi. I search for hi. Some more things which you need to understand. Here is pretty complicated. Might look pretty complicated over here. This is how the first word of a web request defines what exactly type of data or what exactly you are doing with your data. So if it says get means you're trying to retrieve data, you're trying to get data. Then it could say post. The post means you are sending data, you're creating changes to data. And another version of post, or very similar to post, is put, which comes a bit later, and that you don't need to know much about. But again, get and post are your main ones. And these which are, let me just do it full screen. These which are highlighted in blue color over here, these are called headers. Alright, these are request headers. So as you can see, first header is host. So what is the host server? That is Google. User agent, what is a user using? I'm using Mozilla Firefox. It shows that I'm using Windows 10, blah blah blah. So accept language, except encode. These are your headers. All right, and now based on these headers there are many bugs which I will also explain you. And this is your cookie. I think everyone must know about cookie, and it is very necessary to understand what a cookie is. So basically what a cookie is that, let's just say I have logged into my Google account, right? As you can see, I have logged into my Google account over here. I entered the password, I know it, but for example, I just close Chrome off, I open Chrome again, but I wouldn't need to type in my username and my email ID and my password again. Why is that? That is because when I logged in, Google created a cookie, and what did it contain? What type of data was in that cookie? In that cookie there was a data. All right, Anshraj has logged in, so we'll create a session ID. Session ID is a very long list of characters, and what the session ID does is that instead of like when I open my Chrome again, and instead of me typing the password and email ID again, doing blah blah blah, all that stuff, what the session ID does is that Chrome stores the session ID. I open it, and Chrome sees, all right, this session ID is already with me. It sends that to Google. Google recognizes, all right, this guy has already logged into it, we do not need to ask for it again. Session ID this corresponding to my email, so send this information back to me that I am logged in already. So this is one way how cookies are used. There are many ways, there are many types of information a cookie could store, but session cookies are mainly the ones which have are of main focus, and they contain the most important information, as you might already know. Because now try to think as a hacker, try to think what a hacker would think. All right, not username or password, but what if the hacker gets the session ID? Like over here, this is my cookie. Unfortunately I have not logged in, but if I was logged in and I showed this cookie to you guys, and if some of you were excited enough to type this long thing, you could actually get access to my Google account, and I'm not kidding. That is how a cookie works. That is why protecting your cookie is very important. All right, and based on these cookies there are other bugs. So let me just talk about, I'll come back to SQL and other injection. Let me talk about broken authentication and sensitive data exposure. So sensitive data exposure basically means that in any way you are getting access to sensitive data and sensitive data, an example I just gave you right now, and that is cookies. So if you get access to my cookies, so like now you have access. Now let's just imagine in a time frame, or in a thought process of what a hacker would think. So all right, sensitive data information, I got access. What is my sensitive data? That is my session cookie. Got access to session cookie. All right, how can I impact the victim? The impact would be that due to me knowing the victim's session cookie, I can access his or her account. And what can I gain from that impact? What can the hacker gain from that impact? I can gain the user's emails, I can gain the user's YouTube search history and whatnot. See, so this is how you need to think as a hacker. You need to think what exact bug have you exposed, and then what is the impact of that bug, and then how it can affect the data or privacy of the user. All right, so that is sensitive data exposure. Broken authentication is almost the same way, because let's just say broken authentication, again I might be repeating this phrase a lot, but use this a lot, and that if try to understand the terminology from its name itself. Broken authentication means that a way of authenticating of a particular website. For example, in Google, I type my email ID and I type the wrong password, but still Google lets me in. Isn't that bad? Isn't that harmful? So, all right, if I type a wrong password and still Google is giving me access to my account, so that is broken authentication, or the method of authenticating Google that yes, the user is Anshraj, is not fine. is not okay or is not how it should be. That is sensitive data exposure. All right. Now, I said I'll come back to SQL and other injections, and I'm back. So SQL, like I showed you over. Wait, let me just open that. Yeah. So SQL is the language which controls the database. All right. So now let's just again come back to Google. Google has a database somewhere in their facility which includes the username, password of everything. So if I'm trying to log in, then the request goes to the servers. The server says to the database that find the entry with Ansharaj's email ID, which is this, and see if the password he entered match the password with what his actual password is and the password he enters. If they are the same, that means this is Ansharaj himself or an authenticated user. Give him access. But what if you were able to get access to other components of that database? Like that database doesn't only store my email ID, it stores yours. It most probably stores yours and many other people. Wouldn't that be harmful? So that exactly comes under SQL injection. SQL is a website which is finding my email ID and password and correcting it and seeing it. That is a SQL. And if for example in any input field I was entering this script alert one, all right, and I was trying to enter JavaScript. What if I enter SQL code? All right, you can go search in Google sample SQL code, and if you were able to enter this and this SQL code gets executed, that means you are able to enter SQL code over here, and that means you can manipulate the website's database. Wouldn't that be very harmful, right? But on that note, we also need to acknowledge that like some forms of XSS, like I told you, stored XSS is very rare. SQL injection is also very rare. It is very, very rare. So while it does happen, it is very rare, and companies do pay a lot for that. And on the very same note, I must have told you that the programming language which is used to control and which runs the servers is PHP. And just like SQL, the server is the brain of this entire website mechanism. And if you could be able to control the brain, the PHP language is what controls the brain. And if you could be able to control the brain, then imagine how much damage a hacker could do. And this is exactly what happens. If instead of SQL code, let's just search some sample PHP code. If you were able to enter or input anywhere PHP code and it got executed, imagine you could be able to control the server. How damaging would that be? That comes under remote code execution. You're remotely able to execute code on the server or on the database, which you shouldn't be able to do, right? But again, these are very rare bugs. So our conversation, I hope, has been pretty productive till now. Now, security misconfiguration, again, self-explanatory. Security misconfiguration. So over here, instead of you playing around, poking with things, all right, is in this input, am I able to enter this type of code or that? Security misconfiguration comes when the website itself is showing you things which you shouldn't be able to see, or data which you shouldn't be able to have access to. All right, let's just say for an example, in my email inbox, I get emails of another person, Mr. X. All right, these emails should be going to mrx@gmail.com, but they are coming to me, ansh@gmail.com. So did I, as a hacker, did I poke around with things? Did I try to enter some code? Did I do anything? No. But this is still a bug, because why? I'm able to access someone else's data and someone else's private data, which I don't think so they would want me to see. All right. And this is a misconfiguration from Google's side, wherein they are sending this person's email to me. So this is a security misconfiguration. Ooh. Now we are left with two very important, actually three, but these two are very important, and this third one is also, just a second. Right. Component with known vulnerabilities. Let's just see. So let's just have another talk. Today, if you were to create a website, I'm talking about today. So how would you do it? You wouldn't, like over here, like I showed you, you wouldn't most probably go to a web designer who would and ask to write this entire code. Like this would be very costly and time taking. That is how it was done in the old days, and many companies still do it today, but most of you wouldn't have the resources to do that. So what would you do? You would go to a website like WordPress, where they would have the themes for you and everything done all ready for you. All you need to do is customize it according to you, right? And there are many websites like this. But what if the WordPress theme that you chose, let's just type WordPress themes, all right? We'll go to the official WordPress website and see, as you can see, inspector is very. So let's just say you choose just theme 2017, you release your website, very nice. But like, remember what I just said, these themes were not created by you, all right? This was not coded by you or someone you assigned them to code for you. This was created by a third person and you are using it. So you exactly do not know what is in it and what if there is a bug in it, all right? So if there is a bug in this theme 2017, then all the websites created using this theme, they will be at fault. And this is what we call components with known vulnerabilities. That if you find a component where let's just say you find this component and while you are researching that this theme 2017 has a bug, and then now you know that any website which is created this using this theme also has that bug. All right, I guess that makes sense. Components with vulnerabilities. So we are left with another two, and these two are my personal favorites: CSRF and Bruteforce. XSE actually I have written over here, but XSE I won't say is something which you should know as a beginner hackers, or like it's not something which is very common, and I wouldn't say it's worth teaching to you right now. I would make sure I make a lesson on it in the future. So CSRF. So what is basically CSRF? CSRF is actually a short form for cross-site request forgery. And let me just explain this very complicated thing nicely to you. All right. So let's just imagine a scenario. You over here, you have your browser and you're trying to access your online banking, and what happens is that it's very simple. You enter your credentials, it asks for maybe verification, a two-factor verification, and you have access to it. All right, very very nice. But what you are where the place where you are filling your information over here, you would see password, username, password. This is actually created using an HTML tag called the form tag. Again, pretty self-explanatory. This creates a form. So not only a login form, but let's just say you have your feedback forms. All right. So, alright, yeah, like you have these feedback forms. Okay, so these are created using tags called form tag, where you create this. But what if this form tag already has code filled with it, like all these inputs are filled with it, and someone else posts this form for you? Like over here, instead of you filling these things, someone else just you click a button and automatically goes what the hacker wants. I know that might sound a bit complicated, but here is the thing, right? So inside form tags there are input tags. All right, let me just show you that too with an example. Input sample HTML form code. All right, see, input. So input this is where you actually input your data. And over here in this input tag, I could actually add an attribute called value. Okay, so over here, like you can see John Doe, it shows our value. But what if I add Anshraj? I can copy this code. I could copy this code. I could send it to a victim, and what I would do is that I would hide all this. There's an attribute to hide all of this, so this won't appear. All it would appear is a button to them. All right. So when they click that button, my credentials are submitted through their account, through their PC. Let me explain it to you again. So if I can just, instead of type over here, I can type hidden. Right? What happens when I type hidden? See, it disappears. All right, it disappears. It is gone. And what I can do over here is I can input input type is equal to button run. Oh, so I actually haven't given it any name. Just a second. Value is equal to submit. I remove these labels. I make it hidden too, and I remove this. Oh, wait a minute. Sorry. I didn't add the apostrophe. All right. So now you can't see the input field. All you see is a submit button. I send this to a user, and let's just say this is a Google form. This is a feedback form, and the user doesn't know what is happening, the victim, and he or she just clicks submit to it. What happens? They won't know what happened, but what really happened when they click submit is that this form would get executed. The hacker has already entered values which they cannot see for themselves, and the feedback would be submitted in let's just say from what the user would like to submit. It would be submitted in place of the user. I just didn't get the words that time. It would be submitted in place of the user, and the user wouldn't even know it got submitted and what values were submitted. That the hacker did it. So again, let's just think about this bug in the hacker thought process which I told you. The bug, CSRF. All right. What impact could it cause? It could enter data, or it could modify data like a feedback form in place of the user. So is it harmful? Yes. So, but how harmful is it? Like, the user would need to click on a web page, and it would need to click on a button. Like I told you, social engineering. So the amount of social engineering increases, and when that increases, the impact goes down, but still there is an impact. This is called CSRF. I hope you understood that. Now coming on to our final one, brute force. So I think everyone over here might know about OTPs, or one-time password. Whenever we are trying to reset our password, we get an OTP, which is usually from 1 to 0000 to 9999, and you need to enter the correct OTP which you receive in order for that to get executed. But just try and think again. Well, let's just say I take Mr. X's Gmail account. I go to Mr. X's Gmail account. I have no access to it. I click on reset password. It sends an OTP to Mr. X's phone, and of course I have no access to that too. So I don't know what the OTP is. But what if I do know what the range of OTP is, right? I know it is from 000 to 9999. What if I enter every number from 000 to 999? So, and if Google allows me to enter those many numbers, so of course it has to be one of them. So one of them would click, and I would be able to reset that password. This is called brute forcing your way into something. That is why you must have seen that after 3 or 4 attempts, the web page says that you are no longer able, you will no longer be able to enter in it because you have had many failed attempts. That is to prevent brute forcing. That is what we call rate limiting. Limiting the number of times someone can input data into a field. But if that is not the case, if rate limiting is not present, then you can brute force it. All right. And like I said, like brute forcing, like what I explained to you, 0 to 999, if you do it manually, like you type one by one, that is a very tedious process, and I don't think so anyone would have the patience to do that. But for that we have Burpsuite. So what you basically do is that like we have a request and we want to brute force something over, like I want to brute force this parameter. So what I would do is that I would send this to the repeater, sorry, not repeater, to the intruder. Also I'll just explain the repeater to you. So the repeater is a tool for brute forcing. You can still go over here, you first clear all of it. All right, after you hit clear, you select the parameter which you want to brute force. So for example, I want to brute force this query. I want to brute force many queries over here. Instead of hi, I want Japan, I want Tokyo, I want Jakarta, I want many things. So I'd add. So what you are telling Burpsuite over here is that, all right, I want this thing to be brute force. So with every request I'm sending, I want this parameter to be changed. And you'd go on payloads and you would add what you want to change. So you can select what type of payload. If I want numbers, I can type numbers. I want a sequence from 1 to 999. Let's just say let's just keep it 10 for now. Step 1, so 1 to 2 to 3, and I want to start this. All right, just click OK, and you can see over here Burpsuite is sending it for us. So you can click on this request and you can see over here that this is 1 over here. If you click over here, it's 4. One more thing you need to know is, which is very helpful, is the status. So status means how a web request is behaving. What is the status of that web request? And these are numbers. So you might have seen 404, 403. These are basically errors. All right, which means that your web request could not be processed normally, and there was some error. So normally what would happen is that if you're trying to brute force an OTP, you might do 1 or 2 correct ones, but after that it would show 400 or something like that, meaning that the web server got to know what you're trying to do and it's blocked you. But 200 status means that the web request went completely fine. All right. One more thing, like I said, repeater is very useful. It's like your laboratory. You can play with requests over here. So I can play with requests over here. I can type over here. You can search. You can actually type XSS payloads in Burpsuite too. Script, I don't know, alert 1. All right, anything. I'll just send it. I'll see the response over here. This is exactly the response. This is the code of what the response was exactly sent by the server. You can render it like what exactly the web page would look like. That would take some time. You could play around with it, and that's how Burpsuite is very helpful to you. Now that being done, I have taught you all the basics of hacking or of ethical hacking and how you can find bugs. But now to end this conversation, I would like to tell you how you can actually make money with it. And what you have done till now is a foundation in ethical hacking. With this, you can start with bug bounty hunting. Bug bounty hunting is finding and doing independent cybersecurity research. So I can find, like, if I found a bug for Google, then I can go on Google only, and I can type Google bug bounty program. Most big companies have bug bounty programs. So what happens? What is in this is that you can go in these programs and you can exactly tell Google that, all right, I found this, and wait, I'll just show you something. Google vulnerability report program. You can see they have these tables. Those are a lot of dollars over there. So you can go there. They will basically have a form where you will have to fill. You'll have to write the title of the report and wait a minute. You'll have to write a title on the report. You'll have to write exactly what did you discover, and you'll have to write how, if the Google security engineer, they won't accept you like this only, they will try to reproduce that bug themselves and see if what you told them actually works. So you'll have to tell them the steps on how to do it, and that how is called a POC, proof of concept. The steps 1 2 3 4, all right, do this, then do this, then do this, then do this, all right. And that in that process you can also add a video explanation for that. You will be given all options for that. Then you will have an impact column. What would be the impact? Like, you'll have to tell them what impact could this work make, like data exposure. You could access I could access a Gmail user's Gmail ID. I could access their emails. I could send emails from them, what else. All right, then you will click send, and then you guys will work to fix this bug. If they accept the bug, yeah, all right, Anshra just submitted a very genuine bug. This is a genuine security threat for us. They will accept it, and then they will reward you. All right. So this is how independent cyber security research works. One more thing, that companies like Google have their own platform, but there are some platforms like HackerOne where a lot of companies are listed. So this is basically like the intermediary. See, you can see so many companies are listed, and some big ones too. Like you have got Reddit, you've got Amazon too. So most hackers often use HackerOne and hack on such intermediary platforms. Like, you got so many companies you can hack on them, and since you also have an intermediary platform, they also regulate. So for example, if a company says in their policy that let's just open TikTok's policy. So if they say in that policy that, all right, I'll pay you this much for a particular kind of, for a high impact bug, I'll pay you $1,700. And if they like, let's just say they don't hold on to their end of the deal, they pay you less, then you can complain to HackerOne, because they are the intermediary platform. They can actually do something for you. But in case of Google, they have their own platform, so you can't really do that much there. Google is the bully over here. Also, before hacking something, or before ethically hacking or trying to do cybersecurity research, please read the policy page. Please read all of this. This is very important. I know it might seem very tedious and might very long, but trust me, you can save a lot of time over here. And even though you are hacking in good faith, you need to know what your limitations are and what you cannot do, and that is exactly written over here. Also, like TikTok has written over here, their asset priorities, what they would give their greater interest to, like in these things, rewards, and this specifically out of scope. So what does TikTok consider? Like, they won't consider them as bug. So like you have clickjacking, cross-site request forgery. So like I said, if they feel that you have a CSRF, you were able to do CSRF, but it couldn't do anything sensitive or impact any sensitive data. So like they are saying over here, they won't consider it. All right. Well, so I guess that was well over an hour, our conversation, a little conversation. Well, my throat hurts, but I hope you found this conversation not boring, a bit interesting, and you could take away something to learn from that. So until next time, thank you.